Alright guys, so this is our next question from XAT23. You can pause the video and try it out and then resume for its solution. Okay, now there are several ways to answer this question. The first method is a very straightforward, a very standard way of solving such questions. Whenever we are given the vertices of the triangle, the area can be very easily found using a determinant. So the area of a triangle having coordinates x1, y1, x2, y2, x3, y3 is half of the determinant of x1, x2, x3, y1, y2, y3 and 1, 1, 1. Okay, now you can simplify this. I mean, you can open it out if you know to open determinants, or you can remember this as a standard formula. The area of a triangle having coordinates x1, y1, x2, y2, x3, y3 will be half into the next step is x1 into y2 minus y3. So x1 into the next step is y2 into 1 is y2 minus 1 into y3 is y3. Next step is minus of this second term x2, and x2 will be multiplied by 1 into y1 minus 1 into y3. So y1 minus y3. And the last step is plus x3 multiplied by 1 into y1 is y1 minus 1 into y2 is y2. So that's what we have. This is a standard formula you can remember for finding out the area of a triangle given the vertices x1 y1, x2 y2, x3 y3. Although I don't recommend marking it up or memorizing it, because there are many better ways, many awesome, very amazing ways to find the areas of the area of the triangle. So we'll discuss them as well. But yeah, this is one standard way which you can use to find out the area of a triangle. Now using this, we solve this question. So here we go. We know the coordinates of the vertices here. So we can take this is x1 y1, this is x2 y2, and this is x3 y3. The area will be half into x1 into y2 minus y3. x1 here is a, and y2 is b plus 4c minus y3 is 3c. So b plus 4c minus 3c. Okay, minus x2 into x2 here is a into y1 minus y3 is b minus 2c, and y3 here is again 3c, so minus 3c, plus the last term would be x3 here is minus 2a into, this is slightly complicated but we'll be very careful here, y1 minus y2 is b minus 2c minus of y2 is b plus 4c. So minus of b plus 4c will be minus b minus 4c. Okay, so that's what we have. The next step is we will observe b and minus b will get cancelled out, and b plus 4c minus 3c is nothing but c only, and b minus 2c minus 3c is minus 5c. So what we will have is the area is half into a into b plus c minus a into b is minus ab, minus a into minus 5c is plus 5ac, minus 2a into minus 2c minus 4c is minus 6c, minus 2a into minus 6c is plus 12ac, and the next step is we open the first bracket. We are going to get ab plus ac, ab and minus ab cancels, 12ac plus 5ac plus ac is 18ac. So the area is half into 18ac. 2 cancels. The final area is 9 into a into c, which is very clearly your D option. This is one way of solving. I mean, if you don't want to use too much of like logic, you can straight away use the standard method of finding the area. This is one method which we can use here. Now let's look at the second method of solving this question. Alright, so let's go on to the second method of solving this question, finding out the area with the given vertices. It's again a very popular method. It is called as the shoelace method, in which we write the three vertices a, B, and C, the coordinates, one below the other. And then the first coordinate, we repeat it below. We simply rewrite it below. Okay, so we have 4 values written. Okay, any vertex you can write it below, makes no difference. I generally prefer the first one. So that's what we have. Alright, and after this, you have to follow a simple procedure. Pay attention, guys. You have to multiply the x coordinate here with the y coordinate here. So a into b plus 4c is what we will do. A into b plus 4c. When you multiply, you get AB plus 4AC. I'll write it here. AB plus 4AC. Same thing. The x coordinate here we multiply by the y coordinate here. A into 3C is basically 3AC. we add it here 3AC. And the last step is this x coordinate we multiply by this y coordinate. When we do that, we get minus 2a into b minus 2c. So minus 2a into b minus 2c, when we open it out, we will get minus 2ab plus 4ac. Now this kind of simplifies to 4 plus 4, 8 plus 3, 11. 11ac minus 2ab, and ab is minus ab. So this is one thing that we keep track of. The next step is we do the exact opposite. This y coordinate b minus 2c we multiply by a. So we are multiplying a with b minus 2c. It will become ab minus 2ac. Same thing we repeat. B plus 4c will multiply by minus 2a. So minus 2a into b plus 4c. On multiplying, this becomes minus 2ab minus 8ac. And the same thing again, we multiply this y coordinate with this x coordinate. So a into 3c is nothing but 3ac. Now this entire thing simplifies to minus 2ab and ab. It's basically minus ab again. Minus 2ac minus 8ac plus 3ac is minus 7ac, right? Okay, the next step is we take the difference of these two answers we have got, the black one and the blue one, the positive difference of these two. So 11ac minus ab minus of minus 7ac minus ab, right? The positive difference, I'll write the mod here. So this will be 11ac minus AB, minus of minus 7AC is plus 7AC, minus of minus AB is AB only, AB cancels, we have 18AC, and the last step is divide that by 2, we get the area 9AC. Alright, I have gone into like very much detail, too much detail while explaining, but it's a very seamless procedure. The answer for the area is 9AC. Now, if you want to understand in depth how this shoelace method came about and why it works, I have elaborated everything in my course, the complete course for quantitative aptitude. You can check that out in the description. And now let's look at the best, my personal favorite approach to solve these questions. It might not work every time, and that's why I've given you two other weapons to attack the question. But yeah, if you can observe and if everything fits in properly, this is the best method you can have for finding out the area of the triangle given the vertices. So let's start by plotting these 3 points on our Cartesian coordinate system, the x-axis, y-axis. So that's how we can plot the points A, B, and C, given that A, B, and C are positive integers. When we join the 3 points, you get a triangle very clearly. Alright. Now let's start by observing that the points A and B have the same x coordinate. Well, is that a coincidence? Absolutely not. These guys, the question setters, want you to observe this fact. And that is the x coordinate of the points A and B, they are same. If that is the case, you can observe very clearly, guys. The points A and B are lying along the same line vertically. They are one below the other. So B is above A and vice versa. A is below B. In that case, if you observe, guys, the line segment AB's length we can very easily find out by simply taking the difference of these y coordinates here, right? So we subtract B plus 4C minus B minus 2C. We will get the length of the line segment AB in this case. So B and B cancels. 4C minus minus 2C is basically 6C. So the length of the line segment AB we have found as 6C. Next, we'll make a small construction here, guys. From point C, let's drop a perpendicular on AB, and the perpendicular meets AB at the point D. Now, if you can observe carefully, guys, AB is already parallel to the y-axis we have seen because A and B have the same x coordinates. If I draw a line passing through C parallel to the y-axis, I have 3 sets of parallel lines, right? This line, the y-axis, and the line AB. So the perpendicular that I have drawn, it is nothing but the perpendicular distance of these two parallel lines, right? The first line is having the equation x is equal to minus 2a because the x coordinate of C is minus 2a. And similarly, this line here has an equation x is equal to a. It is formed by the points A and B having the same x coordinate. And whenever the x coordinate is same, the equation is x is equal to constant. Now, between these two parallel lines, the difference is the blue perpendicular CD, as you can see. And it is nothing but the difference of these x coordinates, as you can see. Minus 2a minus a is minus 3a. Or value-wise, the length of this line CD is nothing but 3a. So now we are 95% through with our solution. We can observe that in triangle ABC, we can take the base as AB, which is 6e that we have found. And the height we can take as CD, that is 3a that we have found. and the area of the triangle is always half into base into height. So for the required triangle ABC, the area is half into 3A into 6C, which basically boils down to 9AC. And very clearly, this is our answer option. That is the D option, 9AC. All right. Very short and sweet method. You can simply get the answer in seconds. If you observe this, you don't even need to draw the diagrams in this case, guys. If you observe the points here, A, B minus 2C and A, B plus 4C, very instantly you can imagine that these 2 points are one below the other, and this length will be 6C. Similarly, since these 2 points are one below the other, the third point has the x coordinate minus 2A. The gap of these x coordinates is basically 3A in value. The area you can instantly calculate as half into base into height, but that requires certain amount of practice. That, I mean, you should have solved certain questions, similar questions already before. But nonetheless, this is the best method to solve the question. I hope you have understood and enjoyed this video. Please don't forget to like, subscribe and comment. And if you want to understand all these concepts in detail, consider enrolling for my course in the description. I'll see you next time. Bye-bye.